Today, we will learn about metallic bonding. Our question of the day is, what are the properties of metals? Okay, let's do a quick review of some of our periodic table. All the elements on the left side of the periodic table are metals, except for hydrogen. This includes both the D block and F block. Thanks to ionic bonding, we already know that metals lose electrons when they bond. We also know some properties of metals, such as the fact that they are malleable, meaning they can be hammered into a really thin sheet. Basically, you can change its shape a lot. Metals are also ductile, meaning they can be stretched out and turned into thin wires. So, the reason metals exhibit these properties is because their electrons are held very loosely. So that means they have a very low ionization energy. It doesn't take a lot to get them to give up their electrons. Now, keep in mind, almost all metals are solids at room temperature, except for mercury. Hg is an exception because it is a liquid at room temperature. Despite this, when you have a metallic element, the valence electrons will swim around. Yeah, that's right. The electrons swim around even in solid metals. Okay, so what is metallic bonding and how does it work? Think about it this way. You have a bunch of metal atoms all close by each other, right? And they all have a positive nucleus that will attract valence electrons. However, these metals only loosely hold on to electrons, so the electrons can easily switch from metal to metal. So they can easily switch between the atoms. This means that we have a sea of mobile electrons, a sea of electrons that are constantly moving between all these positive nuclei. And that's what gives metals their properties. It's basically a game of hot potato that the metal nuclei are playing with electrons. Keep in mind, not all metals are the same. While all metals do have similar properties, like the fact that they are shiny, ductile, malleable, the degree to which they exhibit these properties changes based on their atomic structure. These objects, a spoon, a penny, liquid mercury, and a paperclip, all have very different properties. For example, it's a lot easier to bend the paperclip than the penny, or on top of that, the liquid mercury is the only liquid there. Plus, the penny has a very different color from all the rest. In a few minutes, answer the questions on the Show What You Know section and come back to check them out. So, we need to identify the type of bond in each compound. Is it ionic, covalent, or metallic? Well, carbon and oxygen are both nonmetals. Two nonmetals bonded together makes it covalent. Now, Pb is a metal, O is a nonmetal. They have opposite charges. They are ionic. So sodium is a +1 charge, sulfur is a -2 charge. They have opposite charges. They are ionic. Then you have chromium. Chromium is a single metal throughout. It's metallic bonding. Then we have CO, or carbon monoxide. Since both carbon and oxygen are nonmetals, it is covalently bonded. Now we have a different CO, this one with a little o, as in cobalt. Now, cobalt is a metal. It has metallic bonding. Let's look at NH3, or nitrogen trihydride. Since both nitrogen and hydrogen are nonmetals, they are covalently bonded. Number 8 is magnesium sulfide, which has a metallic magnesium and a nonmetallic sulfur, making it ionic. Now, SN is 10. that is a metal, it is metallic, and Cl2 or chlorine gas or a dichloride molecule, however you want to say it, is our covalent molecule. Let's keep going. Lead is a metal. Sodium chloride, sodium is metal, chlorine is nonmetal, it is ionic. Dihydrogen monoxide, that is covalent, hydrogen and oxygen. And lithium fluoride is lithium, which is ionic because it has a +1 charge, and fluorine, which is also an ion because it has a -1 charge. So ionic. Now 15 is copper 2 sulfate, which is copper is metallic and sulfate is a polyatomic ion. Polyatomic ions are ionic. Now, manganese, that is a metallic element, that is metallic bonding. So 17 is sulfur hexabromide, which is covalent. Let me tell you a little trick. Anytime you see a prefix, you are going to say covalent. Now, silver, once again, a metal by itself is just metallic. Now for this one, titanium dioxide, guess what? Anytime you have a Roman numeral, it is indeed going to be a metal and a nonmetal bonded together, or a ionic bond. Now, once again, nitrogen trioxide has prefixes because it is both nonmetals and it is covalent bonding.